My name is Khizr Khan. You are watching Learn to Grow, and today we are with the topic wire delta transformation. What is wire delta transformation? As you can gain it from the wording why. So we have a wire type connection of resistors. This is a wire type connection. Okay. And what is delta? A delta type connection. Okay. So when it comes to circuit, when it is in a circuit, so it becomes difficult or complex for us. So it becomes difficult or complex for us to solve that circuit because this is not simply series or parallel. This is wire delta. So they have their own rules, their own systems to solve them. Okay. So here I am going to show you the formulae, sorry, for solving these sort of circuits. When we are wanting to solve a delta into a y, we have these formulas. If we have a delta, so we have RA, RB, and RC. Okay, so we will put these formulas for gaining R1, R2, and R3. Okay, when we will gain R1, R2, and R3, we will have a Y circuit. For R1, R2, and R3, we have these three formulas. Here, the denominator is same throughout the formulae, but the numerator is changing with the resistors. Okay, for R1 it is RB/RC, for R2 is RA/RC, and for R3 it is RA and RP. But if we are wanting to convert a Y connection into a delta connection, we are willing to have RA, RB, RC because we have initially R1, R2, R3. We have initially R1 and R2, R3, and we are trying to get RA, RB, and RC. We will get it from this formula. Here, the numerator will remain same throughout the formula, but the denominator will change according to the resistor. For RA, it will become R1. For RB, it will become R2, and for RC, it will become R3. So this is simple. It is simple to solve wire delta transformation, and let us take an example to clarify it a bit more. Here we have an example of circuit you can see. Okay, so what you can see in this circuit, you can see that this is not making a simple parallel circuit. Instead, it is making a Y connection or a star connection. Okay, this is a Y connection, and if we will convert this Y connection successfully into a delta connection, that it will become a lot easier for us to solve it. The question is demanding us I equivalent. For I equivalent, we must know R equivalent. For R equivalent, because I equivalent is basically V equivalent upon R equivalent. Okay, we have V equivalent of 9 volts. We will try to get R equivalent, so we will get I equivalent from this formula. Okay, this formula is from Ohm's law. Okay, for R equivalent, we will first change the Y connection into a delta connection. Let's consider this one as R1, this is as R2, and this is as R3. Okay, initially we have R1, R2, and R3. Okay, we will get RA, RB, and RC. Okay, We can take any R1, R2, R3 and RA, RB, RC according to REs. Okay. But one thing to remember in this circuiting, that RA should be adjacent to R1 and R2 should be adjacent to RB and R3 should be adjacent to RC. So here R1 should be adjacent to RA. Let's say this is RA, this is RB, and this is RC. Okay, this is RC, this is RA, and this is RB. Okay, so according to our formulas, for RA, we will put the values of R1, R1, R2, R1, R2, right, plus R2, R3, plus R1, R3, R1, R1, R3. R1, R3. Okay, and then R1, 3. Okay, so we will solve it. Here you can see I have simply solved RA and it has a value of 3.6. I'll put RA as 3.6 here. 3.6 ohm. Okay, now for RB, only the denominator will change according to the formula. Okay, denominator will become, for RB it is R2, for R2 it is 2. Here it will also change, and 11 upon 2 makes 5.5. Okay, here RB is 5.5, so we will change it with the value 5.5. Okay, simple, 5.5 ohm. Now we will do the same with RC. The numerator will remain same and denominator will change. For RC it is 1, RC 1, and it is now 11. For RC we will change it with the value as 11 ohm. Okay, now we have all the three values. I'll remove it, it is not looking good. So now I have all the three values. I have successfully converted my Y connection into a delta connection. I can now remove this. I will remove this. Now it is now looking good that we have successfully converted our Y connection into delta connection. Now see how easy now it become after converting into a delta connection. We, this is simple parallel. This is simple parallel. Okay. Now we will simply solve it one by one. Okay. Remove this first. Okay. So this is parallel connection. So for this, the value will be plus 1 upon 2. Okay. 1 divided by 3.6 is 0.27 plus 0.5 is 0.75 and 0.7 or 5, and it is the reverse. So the reverse of 0.7 is 1.4. Okay. Now we will change it from 1.4. 1.4 ohm. We will do the same with this. These two are in parallel. So this is 11, and now I will do the same with these two parallel resistors. Okay. So here this is 11 and this is my 3. Okay. 1 upon 11 makes 0.09, 0.09, and 1 upon 3 makes 0.3, and they combine make 0.039, and basically 0.39. Okay. Uh, so sorry, this is not this, and basically this is 1 upon r, and for r we will do the reverse. Sorry, it is like this, 0.39, and for r we will make the reverse of them as we have made of the other ones. 1 upon 0.39 makes 2.5. I'll directly put the value 2.5. Where was my, yeah, this one, as 2.5. Okay. 2.5 m. They both are now in series. We will simply add them. 0.5, 3.96, 3.96. I'll take any of them as 3.9 ohm. Now they both are in parallel, and for parallel we'll do the same as we did here, as the one is 5.5, 5.5, and 3.9, 3.9. For 1 upon 5, 5.5, It is 0.18, and for this 1.3.9, it is 0.25. Okay, so the value will become 5, 0.43, 0.43, 43, and you know that it is the reverse, so the value will become reverse, and the reverse of 0.13 makes 1 divided by 3, it is 2.3, it is 2.3. We have successfully gained our uh, equivalent resistance. It is 2.3 ohm. This is our equivalent. Now you can see that how simply we have solved, we have analyzed circuit. For I3, for IE, it will now become simple 9 upon 2.3 according to the formula, and 9 divided by uh, 2.3 makes uh, 3.9, 3.9 ohm, sorry, 3.9 amperes instead, 3.9 amperes. You can see that the Y delta transformation has made it possible to analyze the circuit, and this is how our Y delta transformation works. Hope you have learned about Y delta transformation, and if you have any question regarding this, you can ask me in comment box. Share this tutorial with your friends, like this tutorial, and don't forget to subscribe. Learn to grow by clicking on the button right there. I'll see you in the next tutorial. Till then, goodbye.